Alright folks, we're going to prove the area of a circle to be pi r squared. So what we're going to do is we're going to start with a polar coordinate, a polar equation, and that polar equation is going to be r equals d sine theta. And that equation is going to give us a circle. And that circle is going to be on the y-axis, and this will be the diameter of the circle. You could also use d cosine theta, and that would put your circle this way. It would be on the x-axis instead of the y-axis. Okay, so d sine theta. So just know that we could do either. Okay, now if you will recall, in my previous video we talked about the equations. We used the equations that that would let us do calculus with polar coordinates. I proved all of those, and one of them is the area of a polar graph, and we're going to do some area applications here. So here goes. We're going to find the area of a circle. Now, one other thing you need to know about this graph before we get started is that 0 to pi will generate this graph. This is 0 to pi. And if you graph this on a graphing calculator and you go 0 to 2 pi, you'll actually see it draw this, and then you'll see it redraw it. And so you don't really need to do both. One is fine. And so anyway, let's go ahead and do that. So the area of any, and by the way, this is equal to f of theta. Just make sure r is always equal to f of theta. Any area of any polar graph is always going to be 1/2 the integral from a to b f of theta squared d theta. Okay, so here goes. This is going to become 1/2 integral, and we're going to go from 0 to pi d sine theta squared d theta. Now, I'm going to cheat. The diameter is a constant, so I'm going to factor that out. So that is going to be d squared by 2 integral 0 to pi of sine squared theta d theta. Okay, so far so good. Now, I'm going to do a little integration by tables. The integral of sine squared, so that's going to be d squared over 2 times the integral of sine squared is theta by 2 minus sine 2 theta by 4. And that is going to be evaluated from 0 to pi. Okay, so that gives me d squared by 2 times, and if I evaluate from 0 to pi, it's going to be what? Pi by 2 minus sine of 2 pi by 4 minus 0 by 2 minus sine of 0 by 4. Okay, fair enough. Now, what do we have? Well, sine of 0 is 0. 0 by 2 is 0. Sine of 2 pi is 0. That doesn't leave us a whole lot, does it? What it does leave us is pi by 2 times d squared over 2. So that means the area is equal to pi d squared by 4. Pi d squared by 4. Now, what do we know? We know that d is equal to 2r. Fair enough. D is equal to 2r. So, let's scoot our paper up just a little bit. So, a is equal to, if I take d squared and I replace it with pi, 2r squared by 4, which is equal to pi times 4r squared by 4, which is magically equal to pi r squared. Okay, so area of a circle is pi r squared. This is actually one of the ways we can come up with this formula, is using polar coordinates and proving that the area of a circle is pi r squared. The beautiful thing about that is you can do geometry with this formula without knowing calculus and polar coordinates. So that's kind of why we teach it in high school geometry. So, ta-da! All right, let's do one more. Let's use this area formula for one of the problems. So, find the total area of r equals 3 sine 2 theta. Find the total area of 3 sine 2 theta. Okay, 3 sine 2 theta. Now, for you to do this, you really need to know what the picture looks like. Okay, so I'm going to go ahead and just draw this picture for you. So you have an XY axis here. Okay, and if you want to draw this picture, you're going to put your graphing calculator in polar coordinates. You're going to type r equals 3 sine 2 theta. And I would try 0 to 2 pi first, and if you don't see anything retracing, I would use that. If everything traces itself in a 0 to pi, then I would integrate 0 to pi. Okay, but what you're going to see is you're going to see a graph that looks like this. You're going to get a lobe here, and a lobe here, and a lobe here, and I drew that wrong, but that's okay. It's going to come this way, and it's going to go there. Boom, 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 boom. You're going to get these 4 flower petals. They're going to be very symmetric. It's not going to be as ugly as my drawing. And each one is going to be at about a 45-degree angle out into the quadrant. So quadrant 3 is a little off there. But that's what we're going to see. Okay, it's going to look like that. Now, I'm going to cheat. Instead of integrating from 0 to 2 pi, what I know is that this lobe is 0 to pi by 2. Okay, if you just graph 0 to pi by 2, you're going to get that first lobe. And if you graph from pi by 2 to pi, you'll get the second, and so on. Okay? So what I'm going to do is I'm going to say my area is equal to 4 times, right? So because I'm going to find the area of one lobe and then multiply by 4. So that's going to be me being kind of lazy there. So it's equal to 4 times 1/2 integral a b f of theta squared d theta. Okay, so 4 times that because I have 4 lobes. Okay, and if I had 3 lobes, then I'd do 3 times. You get the idea. So that becomes 2 integral. Now, since 0 to 2 pi gets me this entire lobe, my integration limits will be 0 and pi by 2 get me this entire lobe. Those will be my integration limits, 0 to pi by 2. F of theta will be 3 sine of 2 theta squared. Now I'm going to cheat again. This 3 is a constant, so that 3 is going to be squared. It's going to be a 9, and it's going to come out of the integral. So this becomes 18 integral 0 to pi by 2 of sine squared 2 theta. Sine squared 2 theta. Okay? Sine squared 2 theta. Okay? Now, what we're going to do is we're going to integrate this. This is another integral by table. It's going to be sine squared of u. Okay? Sine squared of u. And you got to figure out, basically, it's a reverse chain rule problem, a u substitution type problem. And so this becomes 18 times, and the integral of that is going to be theta by 2 minus sine of 2u, so in our case it'll be 4 theta, over 8. Okay, so this is always going to be double this, okay? Evaluated from 0 to pi by 2. That is going to be 18 times, and we are going to get pi by 2 minus sine of 4 pi by 2 by 8. And that's going to be our pi by 2. And then I'm going to save myself a little heartache. If I plug a 0 in here, I get a 0. And if I plug a 0 in here, 4 times 0 is 0, sine of 0 is 0. So that's going to be minus 0. Okay, that's just going to save me a whole lot of heartache. When I plug in this lower limit of integration, everything in here is going to be 0. So I only have to evaluate the top. What does this give me? This gives me an area that is equal to 18 times, and I get pi by 4. Now, right, because pi by 2 is pi by 4. Sine of 4 times pi by 2. Well, 4 times pi by 2 is going to be 2 pi. The sine of 2 pi is equal to 0. 0 divided by 8 is still 0. So I get 18 times pi by 4, which is going to be 9 pi by 2. That is the area of all 4 lobes of this function. 9 pi by 2. So that's how we find that.